Hello. Today I am going to show to you guys how to solve Atwood machine problems. And as you begin physics, you will see that Atwood machine problems are very common. So in this video, we're just going to go through an example problem of a simple Atwood machine. So what is an Atwood machine? We first have to recognize that an Atwood machine is a basic physics laboratory device used to demonstrate principles of dynamics and acceleration. So the diagram on the right is an example of an Atwood machine. It typically consists of two objects of mass, and it is connected by a string over a pulley. And for simplistic purposes, since we do not want to calculate torque of the pulley and any other unnecessary calculations for a simple subject, we're going to say that the string is inextensible and massless, and the pulley is massless and frictionless. So a typical problem of an Atwood machine is it gives you M1 and M2, and this question specifically is broken into two parts. The first part is to mathematically prove that the acceleration of the two blocks is equal to M2 minus M1 times g over M2 plus M1. And the second part is to do an experiment. You are given experimental values and you are asked the quantities that should be graphed to yield a straight line whose slope could be used to find g, and to plot a straight line and calculate g. So some strategies to solve an Atwood problem is that since there's only one string in the entire system, the tension throughout the string has to be constant. It has to be the same value on both the left and right side of the machine. The second key point is that the speed and acceleration of the two masses are the same. And why we say that is because we define a system that consists of both two blocks and the string. And just some general rules are that the directions need to be defined. The motion always goes towards the direction of heavier mass. Free body diagrams and equations both have to be created. So for this diagram, we see that M2 is clearly greater than M1 in terms of mass. So when we draw the diagram and we draw the free body diagrams, we see that the direction of motion starts from the right side and goes counterclockwise over the pulley and ends up going downwards on the left side. Because first, it's the direction of motion, and second, because mass 2 is greater than mass 1. So now the free body diagrams are shown. As you can see, the tensions are the same since it's only one rope. So now how do we prove that acceleration is equal to this equation? So we first use Newton's second law to write equations for both M1 and M2, which are shown on top. So what we do now is we isolate Ft on both sides since they are the same value, and we take the other sides and we equate them together to get the third equation listed. And then using a little bit of grouping and division, we see that A is indeed equal to M2 minus M1 times G over M1 plus M2. So now we go on to part 2 of the question. We have this equation from part A, so now we see that A is directly proportional to G. So now what we do is we have an unknown value that we want to plot, which is M2 minus M1 over M1 plus M2. So we calculate it all, and the results are shown on the table below. And the graph should yield something like this. So as you can see, the vertical axis is A, acceleration in meters per second squared. The horizontal axis is M2 minus M1 over M2 plus M1. And using an equation, a linear equation of best fit, we see that the slope of the line is 9.6327. So what do we conclude from that? We conclude that 9.63, which is the experimental value we get, and very close to 9.81, the actual accepted value of G, we conclude that the slope 9.63 is the experimental value of G. Thank you for watching, and I'll see you guys soon.